Hello. Hey guys, I think we can get started. Thanks for showing up to our talk, right? I mean, every one of you guys must have gotten one of these Woot monkeys. We might really blow it and suck today, but at least you'll have some fun. So we had a choice of giving it out before or after, and you'll figure out this is Mortimer. He's the Woot mascot.
Monty.
And what we do is just like you have the Olympic Games with the flames and you need to shoot the arrow through it, what we do with this guy is you put it out that way, string, and go. That's it, right? So if you don't like anything that we're saying, Dan makes a better target than me. So feel free to let one of them rip, right? So, and again, this feels a little bit like high school. Everyone's way off at the back. You know, we got a lot of seats up front, too. You can aim at us better that way, too. So we'll go ahead and get the show started. My name's Vivek Sagi. I'm the CTO for Woot. I actually joined very recently, about 4 months back. Prior to that, been an entrepreneur, co-founded a couple of startups, and always thought of myself, used AWS right from the time it came out. Always thought I was on the leading edge of technology in terms of using the different AWS services. Came to Woot, met with Dan and team, and found out that I went from the leading edge to the bleeding edge of technology. Because when you think about scale and sort of security and PCI and all of the different things that a retail company like Woot needs to do, it just magnifies it. So, so that's about me. Dan?
Sure. Dan Pickard. I'm the systems manager. I take care of the systems engineering and infrastructure for Woot. So it's my team that gets to deal with all of the instances and keeping our developers happy.
Great. So we have, I think, a packed agenda. What we have is we'll spend about 50 minutes talking about Woot, what it is. If you guys don't know about it, you will by the end of this presentation. Sort of what our AWS experience journey looks like, what our technology stack looks like. We did want to give you some meat around 2 particular technology throwdown decisions that we had to make, and then we'll end with some lessons learned from Woot. We'll leave about 10 minutes at the end for Q&A, and if you have any questions, only request to just come down to one of the mics. Makes it easier for other people to listen to your questions, too. Great. So with that, let's get the show on the road. So introduction to Woot. We'll have some fun with this, right? So there are a bunch of just 3 trivia questions that we have for you. So maybe just shout out the answers. The loudest one most probably might be the right one. So the first question is, what is Woot? Any takers on that? There we go. OK, so Woot's the daily deal site. We started off with the daily deal site, actually originated the whole product daily deal concept. Very vibrant community. If you've followed Woot for a while, I mean, the Woot monkey, a lot of things that we do are pretty unique to Woot. And we are different than other retailers in the sense that the 2 things we hold dear, transparency, in terms of how we talk about products, good, bad, ugly. And also, we buck the trend versus traditional retail in terms of the data, the content that we share. So let's see if this time around it's correct. The next one. Trivia question number 2. So can you name the event on the Woot web? Bag of crap. And by the way, that's one of the things I'm responsible for. My only job at Woot is to make sure we enable the technology to sell lots and lots of crap. Right? That's what we are known for. That's all we want to do. So that's right, actually. It is the bag of crap. And there are some interesting facts about the bag of crap. You know, we've sold about 250,000 bags of crap since Woot's been there. That's a lot of crap. Most of the time, it is crap. But you do, you know, once in a while get big TVs, computers. I think one time we did Ken Jennings' foam head. It's about this big.
It's about yay big. It's at our office.
Sits in our headquarters. We did actually do a $1 million BOC, bag of crap. That was fun, too. The challenge about the bag of crap is that anytime we put it out there, we really get slammed in the amount of traffic that we get to the site. And we're much better off. There were times when a bag of crap pretty much meant that the Woot website went down. And we got a bunch of flurry of emails from our customers telling us how we sucked at our job and how we could build the technology better. So that's always a good feedback loop to get going, you know? So my legal team made me put this. No Canadians were harmed, right? So the third trivia question, when was Woot acquired by Amazon? So we are an Amazon subsidiary. Who cares? OK, you're right. It is C. So yeah, we are an Amazon subsidiary. And we'll talk about some of the goal today is that it really doesn't change how we do things. We're just a user of Amazon's web services like anyone else out there. And you'll see some of that come through. So that's great. We've talked about this. I just wanted to share 2 more slides. The next one is for long-timers with Woot. This is what Woot used to look like, right? It used to be the one deal a day till it sold out. We didn't have the notion of a shopping cart because you could buy multiple quantities of just that one thing. It was and continues to be very content-driven. So it wasn't unusual for Wooters or Woot customers to come in, find a product, and by 9 a.m. in the morning, it might have sold out already, and you just saw that sold out for the rest of the day. It's changed, right? So if you look at Woot today, we've had a lot of new categories get added. So there are 9 new categories. We've gone from one product that was available to about anywhere up to 2,000 unique items that you can find across the different categories. They're still extremely well discounted. And there are multiple event types, too. So we introduced the Woot Plus flash sales. And that's a single deal is fine. Flash sales are multiple items sold within a flash sale with a different start and an end time for the flash sale. So you heard me talk about the community. And I think the best way to share that is to actually have Mortimer talk about what the Woot community means. And
hey, Monty.
Hey, Mortimer, what's going on?
No time for small talk, amigo. Have you seen what's on Woot today?
Yeah, I think it's like a projector.
No, not the deal. Nobody cares about the deal.
You better hope people care about the deals. That's where the revenue comes from.
Okay, whatever, the deal is very important. But I meant the fun stuff, the site content stuff.
Oh?
There's the product descriptions that are goofy and fun. There's the video podcast, I watch every one. There's the comics and the articles we post on the blog. There's the happy snacking cooking show with its mascot hog. And the Trivial Eye weekly quiz game, plus the thousands of uncategorizable things we do.
Hold up, thousands?
Yeah, check it out, for example. We got a Jeopardy champ who examines common myths and then debunks them.
Oh yeah, I like those posts.
A crudely animated beetle who rants about annoying stuff that bugs him.
Bugs him, I get it.
Insect puns, travel logs for roadside attractions, all kinds of oddball entertainment distractions, field tests of products that we're trying to sell, which do not always go especially well.
Well, transparency is one of our core values.
So maybe people come for the sales, they stay for the yucks, and over time they spend a couple extra bucks.
That's cynical.
That's the patented Woot content recipe.
Not actually patented.
Well, no,
and
but
I feel like you're overlooking the content our users generate.
I'm not overlooking it.
We have like 1 million site visitors every day.
I know,
And that
but
community contributes a lot to the site experience.
well, obviously, you just interrupted me. I was gonna say, we've got quality comments on all of our sales from the most knowledgeable Wooters. Our secret weapon is the nation of Woot out there behind their home computers. They take their screaming monkeys every place. They've even put a couple up in space. They'll show you how to tailor your Woot tees. One guy proposed to his wife via Woot BOC. Huh, they come for the deals, they stay for the kicks. It's an essential part of their daily fix. That's the patented Woot content guarantee.
Okay, again, not patented and in no way a guarantee, but leaving that aside, you totally don't have to convince me of the value of Woot site content. I mean, that's the stuff that raises the profile of our sales and gets people to pass them around. It's the stuff that makes dedicated repeat Wooters out of people who might otherwise just be off to the next daily deal site after one visit.
Totally, that's why they say, if you haven't seen Woot today, you haven't seen Woot.
They don't, nobody said, who's they?
Well, me. I say that, I just said that.
You know what, it is kind of pithy.
great.
So
So that was it, guys. That video was hosted on AWS, and that's how we use AWS. Thanks for coming. Nah. So
we actually do enough video that this time, roughly last year, we actually did 24 hours straight of video hosted out of AWS.
great. So you did see the notion of our content is different, and we'll show you some more examples of that and the kind of technology challenges it imposes on us to share a lot of the content and share it almost near real time. So let's get into the meat of the presentation. So the next thing we want to do, the first thing is, hopefully you knew Woot. If you don't, you know about it now. We'll talk about the technology stack that we have. And so pre-acquisition, Woot was co-located in St. Louis and Dallas. So the company itself was founded in 2003. Very monolithic application. It had, we just had 8 servers. And in 2006, we started using S3 for all the images. We have our own photo studio. So all the Woot images for the podcasts, the blogs, the product content is all our own photo studio. And I think, Dan, we have some fun facts about the S3.
So since we shoot our own products, we actually have, I guess, a bucket full of 1 million images in it at this point that are used to then generate the site. Another fun thing, our cell setup system used to use placeholders for under construction images. We have roughly 28,000 under construction images to fill out those placeholders. Yeah,
our site was under construction for a lot of time, anytime the bag of crabs happened. So in 2009, so because Woot was still doing the daily deal, the community started talking about or sharing other deals that were happening. So we said, let's put together this content into a Woot deal site. We launched that in 2009. It was hosted on EC2. We started off using SimpleDB, but very quickly went to Mongo. And the reason for that was because with the deals and the way the content was structured, a document database was better. We also did a lot of upvotes, downvotes for deals to emerge. And then Solr was used to just index the deals by keyword. And that was a separate part of the site. So for the content to come in and sit on the Woot retail site, we just used the Amazon SQS service to relay that data into Woot retail. So that was pre-acquisition. Dan can talk to you guys about what we did after the acquisition.
Sure. So 2011, we spent about 2 months to build out our infrastructure, get to know the product, get to know the security model. We built a VPN, multi-site VPN between the co-location and our VPC and our offices, and then began the process of migrating the physical server into virtual, the primary ones being SQL Server, since it's a SQL Server-based system. We also brought in replicas for MongoDB and managed to then flip the site into the new environment in roughly 18 hours. And that took us up to 20 servers. Quite a bit of change in the footprint itself, but no major technology changes.
Yeah, Dan didn't get a bonus that year. He said it would take us 4 hours. It did end up taking 18 hours, so not good. So the other thing, too, I think is, no, that was it on that one. In 2012, we decided to rewrite the application. And the main reason was because we wanted to support other deal types. We saw the different categories that we wanted to support. We wanted to support flash sales. Now, the flash sales themselves had variable durations, multiple offers with multiple items. The second reason was also, we talked about this briefly, we needed the changes to be very visible quickly. And some of these you see, I don't know if you guys can read the graph there. It says the first sucker to buy. So we print that on every deal that we do. It shows you a sales by geography. It shows you a sales by hour. And more importantly, too, is items sold out. We didn't want any Woot customers to have a bad experience, trying to think they had something in a cart that they paid for when that item had sold out. So that brought the complexity of making sure that our inventory was always up to date. There were some technology goals, too. The first one was obviously moving to a services-oriented architecture, because, and we'll have a slide later on that talks about it, too. But organizationally and from a reliability perspective, we had to go that way. Site reliability, we've talked about this. Bags of crap almost always brought a site down. They don't do that nowadays. So we needed to improve the site reliability and the response times. We started moving into the cloud. The rest of the presentation will talk to you about that. And we wanted to optimize for cloud deployments and put power back in the hands of our developers so that it could be single-click deploys, but have all the processes in place automated and scalable. And last but not the least, we wanted to build to be language and platform neutral, knowing that technology is changing, the new programming languages, new constructs coming up. So whatever we did, we didn't want to get ourselves logged into a particular technology. So
using those, we primarily C# based, which means our environment runs on mostly Windows servers using ASP.NET, MVC4, and then WCF for the service side of that. We use multiple clusters of MongoDB, as we'll see in the SOA breakout, but quite a bit of MongoDB. Each different environment has its own cluster. And then on top of that, SQL Server takes care of our transactional usage. And recently, as we get into later on, we'll talk about how we're using DynamoDB for that. We also use Memcache and RabbitMQ for message queue and passing. And we use that to keep everything disconnected but real time. Behind the scenes, we'll use pretty much anything that fits. Node.js is one of our newer pieces. We use that for some of the statistic systems, as well as PowerShell and Ruby to do our deployments and automation.
Right. When you're putting the slide together, right, I mean, it was surprising. I'd asked my dev team to fill it out, and it just looked like there were 20 or 30 other things that got dropped out. So I think one of the key takeaways, though, is we do experiment a lot with new technologies that are coming, and invariably they start off either helping on the operations side or the dev side, and then we see if there's a good fit for it, and eventually it rolls up to core technologies. So there you go. We told you what Woot is about. We've sort of shared with you what the current technology stack looks like. So I think let's get to the meat of it, of what our AWS footprint looks like.
So currently, we try and add as many things to the chart as possible. Pretty much the same reason you guys do. Our developers are excited to try technologies, and these things really plug the holes we need. Some of the most interesting ones are actually not on there, but CloudFront we use in front of our, there it is. We use for our API feed. We get roughly 100 million hits a day from CloudFront, from people downloading widgets on their phones or on their browser to find out what's for sale. Yep.
And I mean, if you guys attended the keynote, very interested in the Kinesis that was announced today. And they're also following, Woot's going to be doing a mobile app very shortly. So pretty interested about using some of the mobile SDKs and the A/B test kind of features that Amazon has released recently.
So for our network itself, it was deployed. Since our system's been in place for several years now, we have a more static environment of 3 different accounts. Each one is for a different purpose, of course, a development and staging environment. Our developers have free reign to test and play what-if scenarios. And then, of course, production is much more secured, much more practiced. That links to our existing office infrastructures, one in Seattle and Dallas. And the idea being that the VPC does what VPC is good at, that serves our content, and our offices maintain user infrastructure, backend systems, as well as VPN and the default things. So everything is layered straight on top without any changes between the two.
I think we're doing okay. I only see 2 or 3 yawning people in the front, so far so good. That's good. So monitoring?
So System Center, being a primarily .NET shop, we have quite a bit of Windows systems. So we use System Center. We actually extensively use the AWS management pack. That's really helped us to drive information all the way from the EOB layer all the way down to requests that have troubles. That gives us the .NET awareness that lets us tie into external monitors. And that also really helps us understand how one event cascades through the system. We also use, if you want the next one there. We use OpenNMS for a kind of a external awareness of the system. It does element monitoring, SNMP systems, and service discovery is the big thing. The fact that it also can pull from multiple places within our network to show us exactly what's going on lets us have a multi-AZ perspective.
And I think we might be the largest system center.
As far as we know, the largest management pack user. In fact, we kind of push the edge there, getting information from the CloudWatch system into System Center. One of our more recent things are using StatsD, Graphite, and Skyline. It's part of the Etsy tools. That's allowed us to build fantastic dashboards that we use to talk about data, share data within the company. And that's also really driven the culture of measuring everything available. Our dashboard has, it's only 20 to 30,000 stats inside of Graphite, but the amount of things that we can measure and the insight that's provided is fantastic, partially because of the high resolution. StatsD and Graphite will keep them at a 10-second window and allow it to present it in multiple ways. That also allows us to integrate CloudWatch. We use a big, heavy user of that. We have roughly 25,000 metrics across our network. That lets us see exactly what the system's doing and be able to understand exactly what happens between I/O, systems usage, that sort of thing. And pulling these together has really been our secret sauce. We integrate CloudWatch into Graphite, as well as tracking such as our our RabbitMQ message passing into Graphite as well, so we can see the state change of messages and the events that cause them.
Great. So I think we talked a little bit about services-oriented architecture, and it might have been a great topic 2 years back, but I think everyone pretty much gets it. After we did the rewrite and moved to a services-oriented architecture, obviously we got, I think, about 9 core services. These are the main 4 ones that are important. And you'll see some of the highlights of this is, I think anything that's publicly available is in the security group that's public, like the SG retail public, but Memcache or other kinds of resources that are only needed by that service but in a private manner, they go into the private group. So the security model also very closely follows our SOA architecture. Right. So one of the things we did want to share was the benefits that we sort of expected to get out of the SOA architecture and what actually happened. Right? The first was we absolutely got scale. So if I look at the earlier slide and you look at our catalog service, the catalog service, I think, consumes 70% of all of our capacity. So we could scale that and make that more resilient and robust and get that going without impacting the rest of our stack. The second is, I think, for us, this played out the organizational flexibility. So as Woot grew prior to an SOA architecture, the entire team had to know everything about everything. It took a long time to ramp them up. Versus now, the small teams, each one owns their own service within SLAs. It's really easy to onboard new developers into the team. And each security is important, but each service is now responsible for securing itself, both from a data perspective and also data confidentiality perspective. And last but not the least is the faster time to market. So if you look at roadmaps, we went from one big monolithic roadmap for entire Woot to now each service has its own roadmap, and that changes the pace of innovation that we can do. So overall, I would say the benefits that we expected going in and what's paid off from the Woot rewrite absolutely have been there from an SOA perspective. So great. So now let's, this is all great stuff, but I guess this is the architecture tracks. You're looking for what have we learned and where can we share some lessons. So we'll talk about, technology is changing at a very rapid pace. I mean, we're no different. I'm assuming everyone in the audience is no different. So how do you choose a technology? As you're trying to solve new problems, as you have some bottlenecks that you're hitting, how do you choose a technology? So for Woot, what we've done is we've actually come up with some throwdown tenets. And we do have, I think, a tradition of technology throwdowns. Key things in mind is we go in with very few preconceived expectations. Easy to say, hard to do. Because almost every time we do a throwdown, we've got developers who made up their mind that one is going to come out the winner, right? But you have to be absolutely open-minded about it. Second is, I think if you look at our track record, our favorites don't win most of the time. And that forces us to understand why not and forces us to drill down more. And then you have to simulate real-world behavior, right? Because I think there were some times where we were just trying to say, oh, in a hypothetical situation, this might be better or not, but we're trying to solve real-world problems. So more often than not, every one of our throwdowns actually simulates real-world behavior for what we see from the Woot side based on historical data, and we let the technologies put them through their paces through small pilots and then figure out who won. We do try to compare as many facets as possible. What this leads to is that sometimes you might end up with the best-of-breed solution, and that is okay. You don't need to have just one right way of doing it. Find the right thing for that particular thing and string together a best-of-breed solution. In comparing as many facets as possible, I would say driver support is key because we are a C# sort of .NET platform. So having the driver support to support our development environment is pretty key. And everything else on that slide is sort of self-explanatory, but cost is important too. And what I would say is, as you think about large Woot or any large customer growing, and you're talking about having the site resiliency and having all of the security around it, cost across 10, 100 machines is not, 100 instances is not as much of a factor as it is across thousands of instances. So that does end up playing a factor too. So with that said, there are two examples we'll show you. Dan will walk you through the first one.
So our first one here, this happened right around the time our rewrite was launching. We had to make sure that we were making the right choices for load balancing technologies. We have a long tradition of using most of these elsewhere in the network prior to that, and wanted to find out how should we use each one to use our SOA architecture. That started with Varnish, which we were big fans of. It had been in front of our API service from earlier that year. Very scalable, very predictable, very fast. Nginx, which was, of course, very lightweight and very simple, very straightforward, but it didn't quite have the features we want in terms of optimization. More connections were created, a little less efficient. And Apache, which was, of course, my favorite, use it forever, and it had all the features we want, but wasn't able to tune the same ways that we were able to get their actual winner, which was elastic load balancing. It's worth noting that the product itself went live the week after elastic load balancing began internal services. So we had only a week to kind of finish up. We essentially redo our throwdown to accommodate elastic load balancing and discovered that thanks to its own auto-scaling, it was dramatically cheaper. Thanks to its cloud awareness, it could understand instance failure and AZ failure much better than any of our other options. And that actually leads us to use a best of breed. We'll put ELB in front of other systems or other load balancers to tune features and speed for what we need.
Yeah, this is like one of those things, right? Ask Dan to make a choice, and he can't. He uses all of them, actually. So you want to tell us about where we use some of the other ones, Dan?
Right. So we still have Varnish actually in front of our API feed. It goes actually CloudFront, ELB, Varnish. We still use Nginx for internal services. Apache still does application-specific needs. Interfaces very well with our Tomcat for some inter-services, as well as our internal administrative sites. So we've been able to use really each one for their strongest strengths.
But I think the ELB is pretty much anything that's customer-facing comes in through ELB. Great. The second throwdown was, I want to talk to you about it was a card persistent storage. So if you recollect from the early slides, Woot never had a shopping cart. We just launched a shopping cart in, I think, April of this year, March, April of this year. And one of the goals of this cart service was it needed to be extremely simple. Obviously, it had to be scalable and reliable for our front-end customers. Resiliency was important. A stretch goal or a goal at that time was that we wanted to be able to host a bag of crap and not take the site down. So that was important too. And as you've seen, we've gone from one sort of deal to about 2,000 deals. So it's important that we needed to follow the growth pattern and have customers be able to add multiple items to the cart and check out and have a good checkout experience. So with that in mind, we actually looked at 4 solutions, but they fit into 2 buckets. The standard document databases. Now, MongoDB for us, I think the team thought that was going to be the winner. We had a lot of domain knowledge. We've been using it for about 3 years. It also, we had a significant management overhead that Dan and the ops team had on that front. The relational databases, well known, they supported ad hoc queries, so that was the benefit. I think through the RDS option, we would have had the benefit of not having the management overhead to it. Dynamo had been around for a little bit, but it was fairly new to us.
Right, it had only been out for, I guess, that came out this time last year.
Yep.
So it only been a few months. We'd only had our feet wet just a little bit before diving into this.
So the criteria that we looked at, again, self-explanatory. These criteria, we've got actually a list of about 30 or 35, and we just picked the right ones for each throwdown that we did. In this case, the client API support was important for us. I'll just go into, this is how they played out, right, as we scored each one of these. And Dynamo actually just edged out Mongo. To be honest, we would have been happy with either one, but we'll share why we are happy that we actually went down with Dynamo. It was better than we expected. A couple of call-outs on this one. Performance. Given that the Dynamo and Mongo were our leading contenders, we didn't put Oracle and SQL Server through a complete performance test. We just structured and spent our time on Dynamo and Mongo. And it was a fairly close battle. And like we said, Mongo and Dynamo were definitely the finalists. Where it mattered most, which was performance, and there's a slide coming up that will share what I mean by performance. Dynamo definitely outperformed Mongo in that perspective. The other big advantage to Dynamo was that it was just a push button, and then we could control it up or down in terms of throughput. That really appealed to us versus Mongo, because Dan and team were supporting it, had a significant management overhead to it. Most importantly, one of our goals was we wanted to host a bag of crap. Managed to do that. So cost, actually, yeah. So cost, big surprise, right? And here it is, like I said, as we kept scaling our infrastructure scales, cost is becoming more important for us to manage it. Dynamo just beat the competition out in terms of cost. And this cost was just the cost of the instance itself and the cost of managing the instance, both of them combined. So yeah, this graph, I think, as technologists, we sometimes ignore cost. We look at everything else. But as you start thinking about scaling and then what your scale loads look like a year, 2 years, 3 years from now, I think cost is also and should also become a good factor. We talked about performance. So the three main sort of transactions that we were interested in was adding items to a cart, actually reading those items, getting items from a cart, and then updating the items on the cart, from the cart or in the cart. And especially the get, which was our which is our heaviest transactional call, Dynamo definitely performed. Almost gave us, I think, 700 per second, 700 operations per second better than Mongo. And in the test, at least the way we had structured it, Mongo started reaching its limit, whereas Dynamo, we could have just kept going up and up.
It's worth noting that the actual limit for Dynamo for us was our infrastructure. Being a private VPC, we had to use NAT gateways and actual proxies to leave our network. At first, we thought that would be a huge hit to resiliency and scalability. As it turns out, that actually gave us a lot of additional abilities that if I needed to exit the network in more places, we can add more NAT gateways, we can add more proxies, and still have both the security and speed that we need to do even more. So this is with 3 exit points into our network as opposed to just 1, but we can add more. So on top of that, that doesn't mean that Dynamo was 100% perfect. It actually didn't solve our need for data warehousing and ad hoc queries, as it only supported primary and secondary indexes. We were able to front end that, though, with currently our Oracle data warehouse, but we also modeled up using Cloud Search for the same purpose.
So how did this perform, right? I mean, we've had 20 billion requests to our cart service since we launched. Amazed at the fact that one of our expectations was we wanted a fast, persistent storage mechanism. We've had sub 10 millisecond response time as a goal, and we've achieved that. Even more surprising is no errors since we launched. And we've absolutely had no requirements for maintenance or no SLA misses. So much better than we even anticipated going in. And I think the other interesting fact on this front is that we actually turned down.
Right, we've turned down the knob 3 times since launch. It's actually quite a surprise that our actual needs were less than we thought, and the system responds much faster than we thought.
Yep. So great. So we've looked at sort of the stack. We looked at 2 ways that Woot does throwdowns. Hopefully that's helpful. Coming to the tail end of it, I think 2 things we wanted to do. One was we wanted to talk about some experiences we've had in terms of how do you recover from a cloud outage, and then we'll end with some best practices that we've learned.
Sure. So what's most important here is not that outages are frequent, it's the lessons we take away from them. We highlight this one mostly because of what we learned on our behalf. There was a massive storm which led to some power problems. Ordinarily, the model would be to fail away from that, to move to some other system, but as it turns out, with a SQL Server-based system and Active Directory system, that availability zone housed our central data for both. It took quite a long time for the EBS volumes to come back online, but our data was very stable, very secure. It was essentially the first major outage where we had to explore how to react to that. What we learned was not a problem in the cloud itself. It was actually that our DNS system collapsed as a result. Active Directory was unable to find a master and couldn't update itself and basically blocked against all of that. So,
now, wasn't a SQL Server actually, didn't it survive the power outage?
Yeah, we don't have exact counts on how many servers had been left, but as far as we can figure, we were incredibly lucky to have that server stay on the entire time. So the big lessons to take away from that is that you really need to use the availability zones. In that instance, we were much less worried because we did have a real-time, up-to-date mirror in other zones, but bringing it online is still problematic. It still requires code to adapt or witness instances to bring that online. We also have data replicated out in MongoDB. One of the lessons there is that you can't have too many replicas of Mongo. We've also learned that having additional nodes from Mongo, different replicas for backup purposes, typically much smaller, but long-running queries get their own instances, as do specialized indexes that you don't want the primary nodes to have to deal with. On top of that, the big lesson is queue everything. We use RabbitMQ for everything inside of a given service. It allows us to save state. It allows us to decouple everything in and out. And then it allows us to actually find out where things are breaking. Typically, we make use of an error queue. So that if something times out, if there's a message processing problem, we can recover what happened and rebuild that state. It also gives us a way to regenerate those messages from a database if something happens in flight.
Yep.
So another big lesson, it's not revelatory, but the better you are at keeping hosts disposable, the easier it is to recover from problems, easier it is to scale. We try and hold ourselves to push-button launches that we can decide in a very short period of time that the scale is needed. That also forces the use of centralized configuration. It keeps as little unique data on that host as possible. And for the use of dynamic role assignment, in other words, the image itself doesn't know what it needs to be until it's completely built and deployed.
I think to build on something that Dan said, right, I think the queue everything really worked out for us and enabled the sort of the continuous deployment because it is rare, but it's not unusual for one of our deployments suddenly to affect a part of the site or one of our services. And knowing that we have everything queued up, we can recover from it. And the customer experience per se doesn't suffer. We can recover from it and process things through, whether it might be orders in a cart, is pretty helpful. So as much as you can make asynchronous, put it into a queue and manage, big benefit to that.
And obviously, there's not a lot of insight into outages, but it's worth noting that problems themselves in a cloud deployment generally look like a network problem. It's not the same server problem, the same SCSI or fiber channel problem you would have in a traditional data center. It feels more like a iSCSI problem, that you can't talk to your data, you can't talk to the other hosts, network partitioning, that sort of thing. In the case of the outage before, we actually ended up front-ending one tool with another to find the best balance. We actually put bind9 as read slaves in front of all of our DNS systems so that we have a consistent system that we can always replicate from and always draw from for a DNS outage. That allowed us to continue our infrastructure without losing the resiliency.
Great. So we're breezing through this faster than we expected. That's good. We'll have time for questions. But some final thoughts on the cloud. And actually, I don't know how many of you attended the keynote from Vogler today morning. It was interesting. I think his themes were performance, scale, reliability, and cost. And these are the same concerns whether you're on the cloud or on-premise. And we found that too, is the way you think about things doesn't change, the priority doesn't change, but it's how you approach them, and being aware of the tactical differences is important.
So a big fear point in that same notion is security. And as it turns out, the security efforts and needs really didn't change as a part of our migration, as a part of our deployments. Centralized logging, centralized accounts still account for the biggest piece of security, and the needs really don't change as a result. We've also, we expand that to talk about visibility from problems that, since you can't see what's in the middle, that the applications themselves have to meet that need. And as it turns out, that's the same environment that SOA architectures put you for any other deployment. That understanding what your application is doing, what the state of your data is, and what your dependencies are on the downstream services really makes up for what you need. And that's, as we point there, use the SOA tiers to your advantage. So best practices, kind of an anecdote here. We are using Cloud Search as a part of shirt.woot's searchable index. You can go back and find, based on tags, any of the shirts ever produced, any of them that we have the ability to print for you. And part of that, we actually use the describe domain call within Cloud Search. One of our developers working on that got an email from the Cloud Search team around that time saying, stop, no more describe domains. Evidently, there's a limit to that, and we exceeded it. It's also important that we learned that updates should be done in batches, that it really wasn't designed to stream updates, and it's good that we were pushing the limit there. On top of that, a problem that I know has come up in other talks, actually there's a competing talk right now about the same topic, EBS, optimized hosts, and provisioned IOPS make a huge difference in the data, and especially relational databases. There's a graph for this that we have. There was actually our primary transactional SQL server was suffering from high I/O latency. You can see it in the performance monitor inside of Windows that each disk would queue and wait for a while. Prior to that point, we had deployed lots of disks, typically as stripes, to try and get more bandwidth, more I/O. When this happened, we actually saw all of the disks take on lots of queues, lots of I/O queues here. We transitioned to the slave and rebuilt it as provision IOPS and EBS optimized. And that is the graph off the right side there. It's stayed clean ever since. It really makes a huge difference to not competing for I/O and having low enough guaranteed latency that the system performs well. I also like to point out the line in the middle of the graph is SQL Server bringing the working set back into memory as we failed over.
So this was interesting. Dan and I were laughing. I think it was Parse today in the keynote where they showed about provisioned IOPS and how they got the low latencies but the consistent throughput too. This graph looks very similar to what they had, right? It's absolutely the same. And I think the provisioned IOPS has been that. And then I think the other thing too was how long was this instance?
So the server on the left before we failed over had been up for 420 days. That's longer than provisioned IOPS was a product offering. So we didn't even have that option when we built the system. It's really great to see how that has progressed. So on top of that, scaling, it goes without saying that there's absolutely no reward for using more than you need. Woot has a problem given that we have to scale for our nightly rollover at midnight. You can find all the new sales, as well as new sales launching typically around 9, but we spread those out through the day. And then the standard daily graph that pretty much anyone who gets browsed by office workers views. So we have to scale for our biggest part of the day, but then no more. There's simply no reward for having capacity beyond what we're actually using at any time. In fact, in terms of using too much, we've been able to turn down the number of instances and specifically sizes of instances to roughly 30% over the past year from improving our own practices and using the AWS services to their fullest.
Yeah, especially because when we do schedule our deals and our events, I mean, we talked about the bags of crap. We have things called Woot offs too that get a lot more than normal traffic. So we can bring up our infrastructure to manage those and then auto scale them down once we're done with those events. So let's talk about our AWS experience, Dan. You've been doing this for longer than I have. So what do you think about AWS for us?
You know, it's really fun getting to hear the conversations here because you guys are having the same experience as we are, that the infrastructure, the dashboards, the information that's presented, the Trusted Advisor product really ties into that. It points our attention to where those resources are needed. And I know that comes as a part of the premium support, which we've discovered is useful both in planning what we're going to do and deciding what to do next and understanding best practices, as well as understanding when we do something wrong, and which obviously happens. We're also very pleased with the additional metrics we get from CloudWatch, pulling that back into our existing monitoring systems, into System Center as well as Graphite has really helped us to correlate all of these events together.
Yep. And I think the key thing was, I think the way that AWS advocates for its users, right? And I've had a chance to see this before I came to Woot and from inside of Woot. It's the same. And I'm surprised by the number of times they come in and say, hey, there's a better way of doing it. This is why you should do it, and sort of hand-holding you a little bit. Obviously, we have premium support that helps. The second thing, too, is these tools are evolving at a really rapid clip. So if you think about a couple of slides back, we talked about provisioned IOPS. It wasn't available to us, but now that it's available, and once you get onto it, you just see the processes scream, the throughputs are there. So it's important to be aware of what's happening and realize which of these services it might be time for you to upgrade or get a new instance up. And I think AWS does a good job, at least for us, of telling us, hey, here is something you might want to look into, take a look at it, kind of a thing. And I guess the more we see it, the better it looks. We made a bet, all-in bet, that we're going to be on AWS. And like I mentioned earlier, we're looking at new services as they're coming out, saying, how does it apply? Do we want to use it? Do we want to pilot it and see if it becomes part of our stack?
Actually, one other note there, the elasticity of our capacity, one of our favorite moments in the technical operations team, the day that we actually prepared to move our rewrite from our staging environment out to production, we launched roughly 200 hosts that day to accommodate it. And it was ecstatic to see, essentially a data center appear in our console. So.
Fantastic. That's it, guys. Any feedback that you have, don't forget to give us the feedback. Remember, we gave you the monkeys and the shirts, so that should get us a good couple of votes. We wanted to open it up to Q&A, and